whatever. Do you have? Are you running the stock Android, or do you?
Yeah, hang on.
Yeah, sure. Just give me a minute now. You can run up to the 3rd floor.
The elevator's Boston.
Could also be the Carlo plus 1. Why don't we go ahead and start? What? Why don't we go ahead and start? There's no reason to feel like record these.
You go ahead.
You can start.
Hello everyone, my name is Cole and this is John. We work for Microwave. We're HPC systems integrators, so we build and sell lots of good GPU accelerated systems. And today we're going to give a presentation for you, basically summarizing all the fun information from the GPU Technology Conference that happened a few weeks ago. So what are the main notable announcements that occurred at GTC 2018? They announced the 32 gigabyte version of the Tesla V100, and that comes in both SXM2 and PCI versions. So that's an upgrade from the 16 gigabyte version. They also announced a new GPU, the 32 gigabyte Quadro GB100. And they also announced that the DGX1 and DGX Station will now come with the upgraded 32 gigabyte V100s. And they announced the DGX2, which is a brand new system. They also made some improvements to CUDA 9, unified memory, and they also announced the NV switch, which we'll get further details on.
Okay, so I'll take it from this point, and then Cole will take it from another future point. Some announcements were made about CUDA 9.2, which is currently only available as a release candidate. And they're essentially, they're related to some general system and performance enhancements. There's this thing called unified memory that you're probably aware of that came out with, I think it was Kepler, and they've been adding features to it. Unified memory has become this sort of memory manager autopilot that's becoming more performant. Essentially, instead of having to hand code the memory transfers from host to device, one can instead just use the memory manager, and you should be getting performant behavior out of your code. If not, there's something called the CUDA Mem Advisor that you can use to tweak the default behavior of the memory manager. I'll get into a little bit of detail about that. And the old directives are still in place. You can still do device to host and host to device data transfers if you like. So actually, they did an experiment with Ohio State University. They are developing a fork of Caffe, and what they did was they removed all the handwritten host to device and device to host transfers, and they just let it go on autopilot. And they found that the performance was really not that bad. There was a little bit of a degradation in the speed up, but not so much. I'll show some performance figures for actually what I think is actually maybe another application related to the ITER project. So without getting into too much more detail about speed-ups and applications, so there are a couple of things about the new Volta architecture. They have leveraging of the tensor cores, but you might know that there aren't really any deep learning frameworks out there yet that really make use of them. Now that CUDA 9.2 is going to be optimized a little bit more to take advantage of the tensor cores, we're expecting that there will be some performance enhancements, but you might know just from browsing around or anecdotally that people are finding out that the performance is not really worth the extra price for, let's say, Titan V or Titan 5, however you call it, compared to, say, the cost of buying a GTX 1080 Ti. You're better off just buying 3 1080 Ti's than you are just buying just one Titan V. But I'm sort of expecting that eventually the framework will catch up with the hardware, and I'm finding out that NVIDIA apparently will release a hardware platform and then not really have the drivers optimized and tuned for the hardware. So they kind of do things the other way around that way. And that came as somewhat of a surprise to me. So I decided I would just share that. So yeah, we can go to the next one. Okay, this is just listing some of the optimizations. I'm not going to go through these. You might recognize something here. Of course, there's QBLOS and QFFT and some other things that I put on here. 9.2 features device code improvements. You're probably aware, of course, that there's there are actually arithmetic units that do the tensor multiplication and the addition, but now they're also they're featuring different dimensions of tensors. So instead of I think just 8 by 8, now there's I think 32 by 8, 8 by 32. You have the option of having these things. You can multiply them in half precision and sum them in either half precision or full precision. My understanding was that there was some numerical stability. You might have heard something about it. When everything was done in half precision, there was some problem that I heard about with numerical stability in some applications. With the P100, I don't know if that's why they changed it, so that you could sum and retain, like the cross product. If you consider each of these like a binomial a plus b, you have the a squared, the b squared, and the 2ab. Well, the b, if b is the more precise part of the b squared term, is what becomes what you would retain in the single precision floating point. If you discard that, apparently there were some problems with numerical stability. One thing I should mention is that unlike with previous hardware versions, previous microarchitectures, threads now can be, they can have individual control over their scheduling. So there's this feature called nano sleep, which is supposed to be advantageous, for example, in an application where you have a whole bunch of data-hungry threads and a whole bunch of data-producing threads, and if the data-producing threads aren't producing enough data, then the data-hungry threads will always be querying for whether there's data available, and that can itself take up system resources. What you can call nanosleep, for example, on these data-reading threads, and it will just sort of put them into a very short nanosecond timescale of sleep. So that's something that's improved the performance. It might interest you to know that there's a library called Cutlass, which is actually not using QBLOS. It's available on GitHub. And it's just written in C++. It's a sort of wrapper library, so you can call functions and objects out of Cutlass. And without using QBLOS, you can pretty much get like 90% of the performance that you would get with QBLOS. So here I'm just going to kind of briefly describe some of the new memory policies. So again, the memory manager is really intended to be sort of like a memory autopilot, with the intention being that you can just kind of hopefully someday not really have to worry about hand coding device to host and vice versa memory transfers. You've probably experienced getting errors with that sort of thing, and it's frustrating. And deep copies with like double pointers and objects that have multiple pointers in them are problematic. So this is mainly intended to sort of enlighten the developer and make one's job easier. So with that said, the default memory policy as it currently is constructed is not always sufficient. There's still some non-performant behavior, and you sometimes have to use the CUDA memAdvise. I'm not really quite sure if that's an object or a method, but there's something called CUDA memAdvise, and there are these other associated methods: read mostly, preferred location, access by. Whenever a device tries to access a memory page on another device, if it's not there, it will trigger a fault, and page migration will result from the fault. But you can change the policy such that if you want it to be copied, if it's read mostly, the page will get copied over, so both devices would have a copy of it. So I think that's enough about the memory policies. There's some more information on here, and something to do with a phenomenon called page thrashing that they study with an application called Lulesh. So they're improving the tools so that across all OSs, whether you're using Linux or Windows, you're going to see the same user interface. That used to not be the case. And also, there's, I don't have a picture of this, but there's sort of a nice console where you can get a picture of the bandwidths going to the L2 cache and various other components on the GPU board that are informative, that haven't been in previous versions of the visualization tools. So here's just an example of a code base that was written for, this would be electrodynamic what was it called? Magnetohydrodynamic code for ITER. And what they've done here is they've essentially removed the hand-coded data directives, and they've sort of taken off the training wheels, if you will, and allow the CUDA memory manager to handle all the data transfers. And there is actually a little bit of a performance degradation going from something slightly over speed up of 8 to something slightly under a speed up of 8. But it's not really such a great loss of speed up. And then finally, one could suppose that you might be able to, using both the unified memory model and the OpenACC compiler directives, you might just sort of be able to put in these Pragma ACC kernel compiler directives around loop regions, and then maybe with a good memory policy, the memory manager would just sort of automatically parallelize your application. And this is essentially where things are going. I mean, not necessarily just in the direction of OpenACC. There are all kinds of software tools across the CUDA ecosystem. This is just one example. So I think Cole is from here going to start talking about Quadro GV100.
So now we'll transfer over to the hardware announcements at GTC. So one new piece of hardware that was announced was the Quadro GV100. A lot of people were probably expecting them to announce this because it's basically succeeding the GP100. So it's basically a graphics-capable version of the Tesla V100, except it's named a Quadro card. But this one comes with 32 gigabytes HBM2 memory. Doesn't come with a 16 gigabyte version isn't available. And you can connect two of these GV100s together through NVLink. It basically looks identical to the SLI type connector. This is going to be using 4 NVLink connections. So each NVLink connection can have a bidirectional bandwidth of 50 gigabytes per second. So multiply that times 4, you get 200 gigabytes per second bandwidth between these two GV100s. And that would be basically in a workstation that you can do that. It's kind of marketed, they kind of marketed it more towards real-time ray tracing and basically photorealistic images and computer graphics. But I'm sure it will be great for AI and deep learning as well. They also announced a 32 gigabyte version of the V100. So once again, that's double the HBM2 memory, and that comes in both the SXM2 and PCI Express form factors. Before we get into future announcements, I just want to review the DGX1, which was announced was it a couple years ago? Basically a deep learning graphics accelerator. It has 8 socketed SXM2 Tesla V100 GPUs, and it has 6 NVLink connections per GPU. Each link, like I said before, 50 gigabytes per second. But this time, since there's 6, you're going to be getting 300 gigabytes per second bidirectional bandwidth. It also has 2 old-fashioned Intel x86 CPUs and 4 EDR or FDR InfiniBand cards. So this is what the DGX1's topology looks like. So This legend on the left will tell you what all the different arrows mean. So the top one is, the blue arrows is the QPI, so that's just the link between the two CPUs. The next one is the link to the memory, and then various PCI Express links, which can connect GPUs to switches and then switches to InfiniBand, also connect to the InfiniBand cards, and also these green lines represent the NVLink interconnect. So basically you have two quads, two groups of 4 GPUs. So every GPU in this group can communicate with each other at full bandwidth, so that's 300 gigabytes per second. But if one of the GPUs on this side wants to peer-to-peer with a GPU on the other quadrant, unless in some cases it can connect directly. So, for instance, if you're on this GPU and you want to peer-to-peer to this one, luckily you do have one NVLink here. But if you want to connect to this one, you have to do what's called a hop. So you'd have to maybe jump over here and then communicate that way. So there's an extra latency associated with that, and the bandwidth is also reduced because you only have one NVLink instead of 2, which you normally have 2 if you're on the same quadrant as the GPU you're communicating with. And this type of mesh for the GPUs is called a hybrid cube mesh. So that cube is just basically visualizing the connectivity between the different GPUs.
Those two meshes are not the same. The one on the sort of system architecture on the right is showing only one link between 1 and 3, and only one link between 4 and 6. Whereas your one on the left.
It's not meant to represent the number of links. It's just meant to represent the whether there's a direct connection or not. We can talk about it at the end. Maybe 2 questions. All right. So the next announcement, the DGX2. So Jensen Huang, the CEO of NVIDIA, basically announced that he was introducing the world's largest GPU, is what he called it. So it's basically 16 GPUs all connected together through this mysterious fabric that we're going to go over. So this is an exploded view of the DGX2. It's quite a big system. So it has 16 Tesla V100s. It has 12 NV switches. Has 30 terabytes of NVMe SSDs. It actually has 2 GPU boards, or you could also call them a sled. So basically, this is one GPU sled, and then that's another one. And each sled has 8 socketed V100s on it. And there's a plain card, which basically connects those 2 boards. It has 8 InfiniBand cards and 1.5 terabytes of system memory. Just like the DGX1, it has 2. It's a dual socket x86. Has two x86 CPUs. So the plain card is what connects the 2 GPU sleds. I'm just going to go to the NV switch. So there are several NV switches on that plain card, which actually connect the 2 GPU boards. So each NV switch has 18 NVLink ports. And here's a topology diagram of the DGX2. So all 16 GPUs are clearly visible here. Just like the DGX1, you have the 2 CPUs. And this time you basically have a tree of PCI Express switches. So you have one PCI Express switch coming off of each CPU, and then 2 more PCI Express switches coming off of that first PCI Express switch. But the NV switch is what's really special about the DGX2, because the NV switch basically allows any GPU to communicate with any other GPU in the entire system 300 gigabytes per second. And that's a big difference. It's a big step up compared to the DGX1, where you kind of pay a performance penalty and you had to hop across to a GPU that was on a different part of the system.
So what topology is this? Still hybrid, or is it full hybrid cube?
Fully connected.
Fully connected two-dimensional hybrid cube. Wow.
So, like we said, there are 16 SXM2 Tesla V100 GPUs. So, yeah, each GPU can communicate with every other GPU, 300 gigabytes per second, and that basically leads to a bidirectional bandwidth of 2.4 terabytes per second. The system offers 2 petaflops of, that would be half precision performance, and 512 gigabytes total of HBM2 memory. It takes up 10 U of space, which is about this much. It weighs 350 pounds. We didn't actually put the price here, but it's $400,000.
Is that the academic price?
Quantity one. Laptop.
So basically, what's
Is this compatible with the Optane memory?
Optane memory?
I don't know.
Optane, yeah.
It's all soldered memory, right? Or is it?
No, it's chipped.
Well, the Optane memory is, I know you can use that as like storage, like replacing an SSD. I'm not sure, are you familiar with that, John, using Optane memory as RAM? Is that possible?
It's because it has it's a different technology. I don't know if there's some feature on the CPU that needs to be present.
I think the x86 processor that they're using are older models, so I don't think you can use the Optane memory.
Oh, okay.
I vaguely suspected that was the case. So these are Broadwell. So I suspect that there has to be some feature on the CPU, as you were saying, that would enable the system to be compatible with Optane memory.
But it does come with NVMe flash storage. That's PCI Gen 3 by 8, so that will offer pretty decent performance. So what does the DGX2 enable? Why is it special? I mean, you can reach solutions much faster. You have higher bandwidth between GPU pairs compared to the DGX1 in some cases. You can also develop your applications faster. You don't have to make your applications aware of the connection topology because of what John was talking about with unified memory and how you can basically let the memory be managed basically with a hands-off approach. Here's some results this is from a presentation that I saw at GTC. So they did an FFT benchmark and they compared the DGX1 to the DGX2. So for 4 GPUs, the performance is pretty much identical for the two, which is kind of what you would expect because they're the same GPUs and they have the same amount of NVLink connections. But when you jump up to 8 GPUs, you can actually see that the DGX1 takes a big performance hit because it has to hop across multiple GPUs in some cases. And then in contrast, the DGX2 scales up pretty much linearly. And up to 16 GPUs, the DGX2 is continuing to scale very well. And the FFT problem is it's a unique problem. I don't know a huge amount about it, but I do know that it requires a lot of communication across all of the GPUs. It's a very communication-heavy benchmark.
So they talked about the latency anyway between DGX1 and DGX2.
Let's see, for latency. I haven't seen anything about latency. I've only seen like bandwidth benchmarks. There is here are some results from a data reduction and all reduced benchmark. It's kind of hard to see once again because I took the photo of a presentation at GTC. Yeah, this is basically showing bandwidth. This isn't showing latency. So, you have a question?
So, what's the precision on the previous FFT benchmark? Is it single?
It says FP32 complex.
Oh, okay.
So,
Right.
I would assume that for latency, yeah. The thing about the topology of the NV switches, if you're on a GPU that's on the top sled or the top GPU board, and you want to communicate with one that's on the bottom GPU board, you would have to. So say you're on this one and you want to communicate with this one, you have to first go to this NV switch, and then this NV switch connects to this one, and then you can go to there. So I would assume that there is an added latency associated with that. But the magnitude of it, I have no idea how much it is. It might not be much at all. All right. How are we doing on time? Should we be wrapping up, or do we have a couple more slides?
Yeah, can you do 7 or 8 more minutes?
Yeah.
Is that too much, too little?
No, so that's perfect.
Good.
All right. So the NVIDIA GPU Cloud. I don't know how many people here are aware of it, but it's a great resource. So basically, I mean the way the DGX1 and the DGX2 were designed, they were designed to basically use all the software they're running. I mean, the way NVIDIA wants you to use it is they want everything to be containerized. That way, so when a DGX1 or DGX2 is shipped to a customer, there's almost no software on it at all. It's almost a completely blank slate. And what they want you to do is just use containers. So you load a container, run your application, and when you're done, you unload it. And that can keeps everything a lot cleaner. You don't have to maintain lots of different libraries and compilers and such on the host system. You can just plug them in and unplug them using containers. And the NVIDIA GPU Cloud has tons of containers available, and it's free to sign up for the NVIDIA GPU Cloud. So they've got all the big deep learning applications, and they update them basically every month, and they're always trying to optimize them for their platforms. So you have applications like TensorFlow, NVCafe, Theano, PyTorch, and that's for deep learning. But they're expanding it in expanding it to other HPC applications as well. NVIDIA Docker is what you would need to install if you're going to use the containers from the NVIDIA GPU Cloud. Some of you may have used Docker in the past. It's one of the earlier adopted container applications. But the thing about NVIDIA Docker is basically a wrapper around Docker that lets the container communicate with the NVIDIA cards. So if you were going to run a regular Docker container, it wouldn't be able to recognize the GPUs at all. It's not good at recognizing special hardware. It was designed that way on purpose to be platform agnostic. But NVIDIA Docker basically plugs all the GPUs, all the drivers and libraries associated with those GPUs into the container. What did you want to say on this slide?
Not much other than that these frameworks, these frameworks are supporting half precision. They used to not, now they are. There wasn't really very much more I was going to say, and that these are available through the NGC, and that actually Keras isn't a framework; it's really more a framework upon a framework. And you would use it to program in Theano or TensorFlow. So it just makes expressing a neural network easier.
So, Docker obviously isn't the only name in the container game. Singularity is another one. And it's arguably better in a lot of ways, mainly because when you use Docker, any processes, anything that you do inside a Docker container is executed by the root user. So anybody, it's really easy for the Docker user's privileges to get escalated. But with Singularity, you don't have that issue. You don't have to. It doesn't run everything as the root user. And there are ways to run the NVIDIA GPU Cloud containers inside Singularity. A lot of people would argue that that's a better way to do it, but it does require a little bit of work to get it running. All right, that's pretty much everything we have to say about the GPU Technology Conference. If you want to see more, we have some interesting photos and presentations at these two links. Do you have anything else to add, John?
No, not really. I think that is also about sums up everything I want to say.
All right. Thank you.
Did they drop the price of the DGX one? Because that's what they usually do, right? They come out with a new product.
I think they kept the price the same.
As far as I know, yeah,
But
the
they
price is still the
upgraded
same.
They upgraded it to the 32 gigabyte Tesla V100. So it's got double the GPU memory now. But yeah, other than that, it's I think like 150K, is that right?
That's the right neighborhood, yeah.
Jay, you want to come down? Are you presenting?
Is the CUDA stuff finally compilable with a newer version of GCC than like, I don't know, 5 or 6?
I don't know. I don't have an answer for you.
Well, I mean, there.
Any other questions?
Debbie
Can you send us a copy of your slides for our website?
Yeah, sure.
Thanks.
Grab some pizza, guys. If you need a.
Hello everyone, how's it going? We're representing the Northeastern High Performance Computing team, and we're headed to a competition at SC18 coming up soon in November. So we're just going to present to you a little bit about the competition, what it is, some of the applications that we'll be running this year, and then hopefully if you guys have any suggestions for us, we can take a look at it. So SC18 is a conference that's held, SC is a conference that's held every year, happens around the United States. 2 years ago it was in Salt Lake City, last year it was in Denver, Colorado. So Northeastern has been sending a team there every year for about the past 7 years. And essentially what it consists of is there's this huge conference with all the vendors that's sort of the main event. And then there are all these students that come from around the world, Europe, Asia, teams from Africa that come together and they try to compete together in this competition where you have to set up a cluster on site. You have to run a set of applications within the span of 3 days, and that's under a few different restrictions. So there's a 3 kilowatt power limit, and you're not allowed to be assisted in any way during the competition. So this is just a really great learning experience for everyone that participates, really fun bonding experience with the other teams. We're really excited.
So DGX2 would have been that
Oh,
more
absolutely.
than 3 years.
So we'll just talk briefly about past competitions. These are some pictures of some of our team members. We actually last year in our competition we came first out of the United States and European teams, which is really a cool accomplishment for us. And unfortunately, a lot of our top team members moved on and graduated from college. But now we have this really fresh, young, rebuilding team that we're excited to get started and do a lot of learning. So Right now our sysadmin is going to talk a little bit about our system.
Yeah, so our team setup, we have a sysadmin who's kind of in charge of the hardware and software, more of the software end of things, just so that someone has a very deep understanding of what's going on in the system. And so, I mean, it's pretty rough at this moment, understandably, because the competition will be in the end of the year. But based on initial power estimates, we're thinking of using 3 nodes with 2 AMD EPYC 7601 chips each, and then 3 NVIDIA V100s for each one of those. And then we're going to be using InfiniBand to connect between the 3 nodes. NVMe SSDs, big plus for memory usage. And then on the kind of software side of things, we're going to be using Ansible. We've had very good experiences with that in the past for managing permissions and package management across multiple nodes and keeping everything in sync. And we're looking into using some next-gen file systems as well, such as maybe ZFS or BTRFS, because there is an additional challenge. At some point during the competition, the power will go out unexpectedly without being announced, and we're looking into something that will be very robust against that sort of unexpected occurrence.
So unfortunately, one of our team members couldn't be here tonight, but we're just going to now go through some of the applications and talk about the different ways they're going to test us during the competition. So one of the applications is part of what's called a reproducibility challenge. So a big initiative inside of supercomputing nowadays is to make papers reproducible. So using things like containers and detailed documentation so that someone else could take what you did and reproduce it in their own, on their own clusters. So this is actually a earthquake simulation software where there's a paper written on this, and our goal during the competition is to reproduce the results of the paper. And so we actually have to write out a full-fledged sort of write-up, and then there's a journal that SC has internally where these papers are actually going to be published. So this is a really great opportunity. We were looking at some optimizations that we could look into for this application. So right now, there are a lot of calls to MKL, the Intel math kernel library. So potentially we'd be looking into AMD equivalents that we could replace, maybe going into some of the source code to see if we could optimize more for our system.
So, hi, my name's Justin. One of the benchmarking tools and software libraries we're going to be using is called LinPack. And what this does is it uses linear algebra to kind of break down the processes, excuse me, break down the processes and distribute them across different cores. So, yeah, just using parallel computing as much as possible. And so the three main challenges and different ways we're going to implement this is problem size, block sizes, and grid sizes.
So to add on to that, LinPack is basically how supercomputers are getting compared nowadays. The one with the highest LinPack, there's a list of top 500, and the one with the highest LinPack score kind of wins it. The challenge really is to cut down the problem into a perfect size that really fits the hardware that you build in, because your hardware is distributed at different levels of memory, some fast, some slow. So you have to distribute in such a way that it maps perfectly to your hardware, and that is where you'll gain in performance, because we do have a limitation on power. So the best way to do it is to map perfectly on a memory so that we do not waste computational power in communication.
So I'm Jason everyone. Another application is called OpenMC, which is a Monte Carlo simulation. I think it was developed at MIT, so stop me if you heard about it before. But essentially it just simulates the motion of particles and takes many random samples. I mean many random samples. And it's pretty basic program flow. This is an example that I found. Essentially you define a unit square and cut out a section that's some ratio of pi between them, and then you plot particles randomly within the unit square, and then the ratio of particles that land inside versus outside should be pi. And the more particles you have, the closer you get to pi. So that's essentially the idea behind it, and we'll be looking to tune it as well as we can to our system. The input and output is pretty manageable. And the website said that it scales nearly linearly to 100,000 cores, which we probably won't have, but good to know. And it does very well on GPUs because of the inherent parallelism of simulating particles. And a GPU's job is for geometric or complex geometric simulations. So we're looking for it to perform very well in our system.
And then the last application, which is really interesting, is called Cordovoid. So this came out of Uber. Essentially, Uber was trying to train a bunch of deep neural networks and came up with their own open source sort of wrapper around TensorFlow. So the idea of what they were changing around or messing with was essentially right now with TensorFlow, if you're training deep neural networks, the paradigm generally is to have something called a parameter server, where if you have a bunch of nodes, you do some sort of like batch gradient descent where you take batches of input data, train on a node, and then get updates to the parameters of your deep neural network, which you then send to a single server. So Uber, while profiling some of their deep neural networks, found that this actually caused a lot of network overhead when they were trying to run massively parallel applications. So they ended up coming up with a new algorithm called the ring all-reduce algorithm, in which you'll still do node-based batch input gradient descent calculations, but instead of sending those updates to the parameters of your deep neural network to a single node, you'll actually send different updates to other nodes within the system and do this sort of like, each node sends updates to every other node in this sort of circular fashion, all reducing into the same updated model in the end. So it's a very interesting application where it's MPI based. There's also an NCCL NVIDIA communications library that we're looking into using. And I think it'll be a really interesting application. And then there's also a mystery application, which Kurt always has a guess about what it could be, which we can talk about.
I'm over 2.
Over 2. So yeah, basically like you get there and then there's a fifth application that you don't know what it is at all. And so you have to sort of be ready on your feet and you tackle that in real time. So that's all we have tonight. If you have any suggestions or feedback on our system or our approaches, I'd love to hear it. So thank you very much.
These EPIC systems support GPU direct?
I believe so.
Because that could be a huge thing.
Yeah. I mean, one of the big benefits of the EPIC chips is that they have a lot of PCIe lanes, which is something that Intel doesn't really compete with.
Actually, we are having a harder time to find a node that supports those many PCIe because the CPU supports them, the nodes don't have them. So we have a lot of PCIe pins on our CPUs, but we don't have nodes that kind of make use of them. The chips are great, but yeah.
Sure. How much data do you actually have to write to disk as this goes on?
It really depends on the application. Yeah. So I haven't looked too much into the application.
Because ButterFS has data corruption, ZFS is slow. I use it for
of course there is some.
If you're really trying to bomb it, right?
Yeah, there is some performance overhead associated.
But it can be severe, right? Because it has to journal everything.
So that's definitely something we'll have to test and look into.
Well, do you have to have the so you're worried about a power outage, and then you basically don't want to lose data? Are you concerned about corruption, or?
Yeah, either corruption or having some inconsistent state at some point. Either of those would be pretty bad.
So, and you don't want to have like a separate storage server thing on the network?
No, that would be very slow, I think.
And there's a power cap that will be included in the power cap.
That's why we can't use the other
GX2.
Yeah, GX2.
I haven't heard about such. It's not something I had asked in a long while. Are there GPUs that use ECC memory yet?
ECC memory? I'm not sure. I'm not sure about that.
HBM2 does allow ECC. I don't know if the chips use it, but the spec does allow it.
It does show in the console that they have.
Since if you're talking about reproducibility,
all Tesla GPUs have ECC there.
Yeah, so if you go into the console, it does show up with the ECC.
But you can turn it
You
off.
can turn it off.
You can turn it on.
My head.
I think default is on.
Yeah. if you're trying to do reproducible, you want ECC.
These applications you get that they hand you code and you gotta compile it, and then if you're gonna use a GPU, you have to write your own interface to the cards? Is that how?
So mostly it's just, it's a lot of compilation, troubleshooting and enabling. So essentially a lot of these applications will have CUDA ports that you just have to compile against and target for your system. So it's mostly like optimizations in terms of the running of your application rather than
so they've already ported it for you to the card. Okay.
Plus, there are a couple of libraries in the market that you can try. See, for linear algebra, there are a couple of libraries by every vendor. You can try the one that fits you the best.
What's the 3,000 watt power cap? Is that an average or is it a maximum?
It's a maximum. 3,000 kilowatt hours. So actually, if you go over it, they ring this big bell, and somebody comes over, and you can lose, I think, half a point on your overall score for each time you go over. So our system right now that we have spec'd out is actually around 3,700 kilowatts total. So we're planning to do things like downclocking and targeting which applications we're running at the same time in order to remain under that power limit. It's sort of an interesting dance of how much you want to actually get.
3,700 kilowatts or 3,700 watts?
Kilowatts, yeah.
Well, actually,
no, sorry, 3
they
kilowatts.
changed it this year to exactly 3,000 watts. Last year it was like 3 kilowatts.
Thanks. All right.
200 gigawatts.
Yeah.
So you're looking at 3 compute nodes, you said?
Yeah. Yeah.
Okay. And there's 9, so there's 3 V100s per node?
Yep.
That is what we intend.
That's our plan. Anyways.
Okay.
We'll have to work out the hardware. We're still working out the details in terms of sponsorships and the exact systems, but this is in the pipeline.
So I think last year we had 4 nodes with 2 on each, and the things we realized was that a lot of these take a lot of power in idle state also, even if they are not doing anything. So we want to like dense it up with least nodes and maximum GPUs. I think that is the best strategy to go.
Yeah, that's a good idea.
Yeah. And you're also not allowed to change your configuration during the competition. So there are some teams that wanted to come in with a node stacked with so many GPUs for the benchmarking application, and then switch it out for something more reasonable for the CPU-bound applications. But you're not allowed to change your configuration during the competition.
So the Monte Carlo simulations, those are like what are those going to be hammering the most? Like, is it just raw like GPU compute, basically? Because there's not going to be any communication really going on until the very end of the simulation, maybe something. Right?
Sure. Pretty much, yeah.
Monte Carlo does exploit a lot of parallelization. There is least communication, so it will be more on the lines of just submitting the job to GPUs and then getting the results back. Not a lot of communication over there.
How much memory do these nodes have?
That's another thing we'll have to look into. We're looking around something like, I think 256.
Yeah.
Yes.
Along those lines, 56 gigabytes.
Are you planning to use like the memory as RAMFS as well for some of the applications?
RAMFS.
We'll have to.
Is that a suggestion? RAMFS?
Yeah, so you can basically mount your memory as a file system by default. All kernels can do that. So your read-write speeds to RAMFS is much faster. And like Ubuntu kernel has a basically a flag or some variable you change by default is like 10%, but you can change it to as high as like 90%.
Sure.
And 50% is a good number. So up to 50% of the memory, so 128 gigs, you have this really fast 128 gigs memory or file system you can write to. And then you can move data off of that. But basically you have to be careful with the reliability of things, because you're using your memory, so you can use it for some things that are not memory intensive. So, something like OpenMC, for example, that could be an easy target. Sysol is an earthquake code, things could get dicey with that. So it could be like application level. And this is also good, like but the issue is if the power goes off, then those contents go away too.
Usually while our operation, we try to downclock the CPU, but we don't try to downclock the memory because the memory is as it is slow as compared to computations. So if we try to do RAMFS, we haven't yet done it, but then I think it would kind of start hitting the power limits more often. There'll be a lot of power usage on the memory side.
Thank you for the suggestion. We'll try it. Okay. Did you have any predictions for the mystery application?
So no, I do know when they're going to pull the plug on the. So whatever. So are you guys saving state, or you're just going to run naked to the finish line? Because whatever the most compute-intensive thing is, they're going to pull the plug like 5 minutes before the job is over. So you're going to lose everything. So I'll have to figure out. That's probably OpenMC.
Yeah, some of these applications have built-in checkpointing. So last year we were able to run, for at least one of the applications, you just basically write to a file every once in a while, and then you can just start up again from that state, which is really awesome.
Yeah.
But we'll be researching that more as we go.
Which one did they pull the plug on last year?
Well,
This is a new challenge for this year.
Oh no, it's actually, yeah, last year they pulled it during basically like general compute time, so you could be running any application you choose at that time.
Oh, that's right, yeah. Like day 3 or something.
Yeah, day 3.
They did it in the morning.
I think it was like 4 a.m.
4 o'clock in the morning.
Has anyone ever actually invested in getting, simply using a UPS?
No.
That's not allowed.
Not allowed.
That would make life
Can you
very
use a
simple.
supercap? No, it's a non-stupid question, because if you're using ZFS, there's a product called the DDR drive, which is a DDR write accelerator, which takes the log, and it has, I have one, right, and it has a super cap, so if the power goes out, it'll dump whatever's in the cache to, it has enough to put it in whatever 4 gigs of flash, and then you don't lose anything.
For how long is the cap good for?
Just enough to take what's in the log file that you're going to write out. So if it's whatever it's caching, and it has 4 gigs of DDR DRAM, and so there's just enough power to back that up.
Oh, I gotcha.
To the
so it's
4
non-volatile
gigs of
because
flash.
the downtime is like 20 minutes. So cap won't hold that long, will it?
I mean, the other thing you could do.
No, you have to stop, but I mean, presumably, but the point is that presumably you're not running when there's no power, right? So if it's, if you have a few seconds, it'll kick in, and then it'll back it up, and then when you get your power back on 20 minutes later, it'll automatically flush it out to the disk for you.
The other thing you could do is you could use a job scheduler like Slurm. Slurm has APIs for checkpoint and restart. So if you have Slurm running on these nodes and you submit a job using that, and then if you like put the APIs in, then obviously that will like basically checkpoint your application, even if it's a power figure or something like that.
For sure.
That makes sense.
All right, let's get Professor Guillaume up here.
Thank you so much.
Pardon me? I think you should have one of every. This is you need the new Mac one or the old Mac one? Need that one? Okay.
I got one.
It doesn't work with HDMI?
Yep.
Yeah, the main HDMI cable. Hold on.
If you use HDMI, hey Kurt, if you're going to use HDMI, can you continue going through the recorder?
Yeah, that's what he's going to do.
Okay. It looks like the light turned green again, so once the video is active, you press the button to turn it red.
What do you want me to do?
Press the button to turn it red. The video has to be, I think the video has to be going through before it will respond.
Okay.
Okay, try press the button there. Take a look.
Oh, you have to go in the mirror mode or whatever the Apple equivalent is.
So it's shut, so it basically drops across. Drops in the state.
There you go.
Okay. Power supply.
We're going to send in a proposal, yeah.
So, is BU going to take the BU or?
No, it's 100% BU, so it'll just be BU.
Oh, the video's for that.
2015, Northeastern, BU, and MIT and Harvard were in one team. But in 2016, we split into Northeastern and Boston Green team. And 2017, again, Northeastern and the Green team. So maybe in 2018, we will have 3 teams from Boston, BU, Northeastern, and the Boston Green team. So for Boston Green team, our team captain is Evan Donato. He went to Salt Lake City, went to Frankfurt, went to Denver, and we hope we will go to Dallas. And we realized from other schools' experience, they have these generation gaps. So we've tried to bring new people into our team. So this year we will have 2 new members. Kristen and James here will be our new members. And Michael went to Denver, and Christian went to Frankfurt and Denver. So we have about half of the team with experience, and the other half are new people. We work with Bridgewater State University. They promised to give us more than 1 student.
Oh, nice.
Our hardware. This is an old picture with the box is the microwave octoputer. It can hold 8 GPUs. These 8 GPUs were Pascal 100, but now we have the 8 Volta 100. Yes?
So what speed are each of the GPUs connected?
What do you mean the speed?
So like you can have PCIe X16, PCIe X8.
Yes, they are all PCIe 16.
8 of them on one node.
There is each CPU has 2 PCI switches, and each switch connects to 2 GPUs. So in total, there are 4 switches with 8 GPUs.
Okay.
And this is the NVM SSD, and the other is the FDR card, EDR card.
This is not the single root complex one. Microwave also sells one of those, but that's not this model. What's that called? Number smasher or something?
They all begin with number smasher. Actually, this is they're called the octoputer, which is a bit of a misnomer because when you have up to 12 GPUs, it's no longer actually 10 GPUs. It's no longer an octoputer.
Okay.
So we never really settled on a correct name for the 10 GPU system.
So the first node was from last year. We installed 1 terabyte of memory and 2 22-core Intel CPUs. But when we were in Denver, we realized those Asian and European teams have the Skylake processors. So we are going to buy a new computer from Microwave with the Skylake processors. And we also realized for some applications, GPU wins no matter what. But there will be 1 or maybe 2 applications where we have to use the CPUs. So we plan to configure the second node with a higher performance CPUs with fewer cores, with but higher clock speed, and we are going to go for less RAM, just for high speed applications with small footprint.
How many watts is each one of these nodes?
Oh, we are way over the limit. On clock. But when we are not running the GPUs, they sip very little. And from last year, the top team has 16 GPUs. They down clock. They ran 16 Volta 100, but almost at half speed. And that's how they won the first place. So we are going to try this strategy. severely downclock the GPUs to get the best of the curve, performance curve per wattage.
So in a way, you're using power allocation to dynamically reconfigure your cluster. Like you basically run everything at much lower power than max. So if you have something CPU limited, you shut your GPUs off, right?
Yes.
And
So
right. So
doing
instead, you're sort of relying on software to sort of reconfigure it
Yes.
in effect.
Exactly. We use NVIDIA SMI to set the clock speed one by one. Every GPU.
So you'll always fill your power envelope dynamically, basically.
Yes. We need to tweak the bias, the voltage, to get the to match the 8 cards of the performance. All 8 cards show the same performance, and just under the power limit.
So this is like a non-cache constrained limit. Like this only works when you don't you have excess capacity that you do not have to finance.
Right. Also, another thing we learned from last year is the Asian teams use AVX assembly to speed up some CPU applications. But last year there was one application, Born, which is hostile to GPU computation. So the Asian teams used AVX assembly to speed up the CPU computation. And that's one of the reasons we want to go with the Skylake processors. Skylake processors have AVX 512 instructions. So, and our team members, Evan, James, Michael, and Christian, all learned AVX assembly in my class. So hopefully this time we'll do better. And then I also learned CUDA programming in my class. So we will try to.
One tip I can give you on that is Intel's compiler tends to be extremely high performance if you are on the current chips.
Yes.
If you're one generation back from the current chips, performance starts tending to start going through the floor, and of course if you're not on an Intel processor, performance of their code is horrible.
Yes.
But if you are on the current generation Intel processors, their compiler is really good.
Yes. I noticed sometimes my code has a 5 times difference in performance between ICC and the GCC. So these are the standard libraries, software. We are still on CUDA 9.1. These are the applications, and the Northeastern team has already described these applications. We are working on, we are going to assign 2 people to one application, and one person has 2 applications to work on. So we have some overlap of expertise.
So you don't get these applications till you go out there, right? Or do you have them already and you're already working on them?
Yes.
Oh, you already have them?
We can download. In the past, NVIDIA released a new binary for LINPACK right before the competition. And for the past 2 years, in 2016, they offered 8 Pascal cards to each team. And for 2017, they offered 8 BOTA 100 cards for each team. So I'm hoping they will offer 8 BOTA 100 with 32 gigabyte RAM to the teams. If they offer this, we will bring 8 BOTA 100 with 16 gigabyte and 8 with 32 gigabyte.
So the only app you don't have is the mystery one. Is that
Yes.
right? Yeah.
Yes. The way I see this, the horrible and OpenMC and the reproducibility all rely heavily on GPUs. So if they come up with, if the organizers give us a CPU-heavy application, the mystery app, And I will see whether my students can compete with the Asian teams in assembly programming. That's it.
Is one of the things you have to look at reproducibility? I don't think this happened that way last year, but is it possible they're saying, okay, the AMD EPIC system and the Skylake system, did you get the same answer to 120 decimal points? Is that part of the reproducibility?
They say you can say I can reproduce their results, or I cannot reproduce their results. It's not whether we can exactly do the same thing. It's just we show the evidence.
That's right. That's right.
I think a lot of it would rather depend on the kind of libraries you use rather than the architecture will also decide, but then the libraries will also kind of, even if it's the same architecture, the libraries each team uses will also change.
Yes.
I have a question, and this could also be for the other group too. Since you're trying to basically downclock the GPUs and the CPUs and subsequently reduce their power draw, I bet that the heat, the amount of heat that they're generating is substantially lower. So you could probably get away with maybe even removing some of the system fans or going with liquid cooling with a very...
Nanyang Technology University from Singapore last year won the first place. They actually went into the Linux kernel to turn off the fan for the 1 minute when they run Impact. Because when they figure out the exact wattage, they turn off the fan, run 1 minute, and turn back the fan.
I wonder if that violates warranty.
Well, they're going, they don't need one.
Let's get the BU students up real quick, and then we'll be back on schedule.
About how long? We get somebody in Hong Kong. We have Alexi in San Fran and Jarbucks in Hong Kong.
Okay, we'll be quick, 10 or 12 minutes.
Yeah, we don't have a PowerPoint at all.
Okay.
Take less than 5.
So you can start setting up if you want. They don't have a PowerPoint.
Great.
I'll help you out.
Hi, I'm Natasha.
And I'm Vijay.
And we are from BU, and we decided we wanted to also compete in the student cluster competition this year. And so we have a new team of all computer engineers, and we are excited to be here.
All right, so BU used to compete until 2016, and then all of our CS people who used to participate in the SCs graduated, and then last year we had no team go to the SCs. So this year we're starting to rebuild the club from the ground up under engineering, and we have about 7 to 8 people in the club. The rest of the 4 members who are applying to the SC with us could not come here today because it was very last moment, which is why we also don't have a PowerPoint. But all of us are new. None of us have been to the SC before, so it's a very new experience for us. And that's pretty much it.
So one of the things that I was looking for at GTC was Jetson presentations, and out of the 1,000 presentations, there were like 8 Jetson presentations. But the guy who's the head of the embedded division says they're going to come out with, in Jetpack 3.3, they're going to come out with a GPU direct version of their stack. So you've already got the unified memory access on the Tegra core. You've got shared memory between the GPU and the CPU. Well, now you can stick an IB HSA on there. You can stick not a really good like an FDR card. Well, you could put an FDR card, put a halfway decent InfiniBand card on there, and then talk direct to other GPUs. So if we get that, we may be pretty competitive because Jetsons only use like 25 watts. So we'd get 64 of them, and we'd still be under 3,000 watts. But it's going to be close. Our deadline to send this paperwork in is Friday, and then our final hardware spec has to go in first week of October. Does that sound about right? So we're going to do some Jetson experiments over the summer.
The Jetson would potentially work out really well because 4 of the applications, all except the mystery app, are super reliant on GPU compute. And even if we do need CPU compute, there's enough power in those 64-bit ARM CPUs. What do they have, like 4 cores, right?
Yeah,
so
4 good cores, yeah.
that could be enough. So we're banking on mostly just hedging our bets for the GPU stuff and seeing how that goes, mostly.
Cool, thanks. So if you need to take a bio break, the men's room and the ladies' room is right outside the door. So we're right outside it.
So how do you think we should do this? We have 2 people from remote, one in San Francisco, the product development lead for Privacy Badger. So this is a bit of a shift in focus. And then we have somebody in Hong Kong who is really a guru of ARM, low-cost computers, and he's been on this guy Charbucks, and how people have seen him, but millions and millions of people have seen his videos of, he's just taking, if you haven't seen any, you should, because he's taking people through amazing tours of all these chip factories and tablet factories and notebook factories throughout, you know, kind of China and Shenzhen and so, okay, so that's okay actually, because this is, it's a screenshot that's a little bit blown up, so that actually is pretty good. But it does look like what we're seeing here. So, so this is like the external screen, I think, and this is the local screen. Now, Kurt and I, we tried this to work it out. We gotta get the audio up on this.
So I think this is gonna save us.
You have the magic dongle here. Okay.
Well, this is how we get audio.
Yeah, so this is how we get audio, because we. So we're going to use the system Jitsi. If people ever, you know.
Oh, VGA.
Yeah, we're going to use VGA. So, and the reason we're going to use VGA is because
to get the audio.
We weren't able to get the audio with the HDMI. This John has a magic, actually, another adapter to.
Yeah, I'm getting it now.
You need help? You need help?
No, we're okay. We just, the only way to get the audio over the speakers is to use VGA only. You can't mix and match. So.
Actually, so let's see, we just. So is that on VGA still?
Well, you're good to go. It recognizes you as me.
Okay. So the audio is in here.
And it.
This is the.
So, oh, I see. So he's checking
No.
the audio to get the audio.
USB right here, right?
That's USB.
Otherwise, it goes to the HDMI.
This is more laptop.
Oh, okay.
I think, and then it'll get the audio off the speaker. Probably mine.
So good.
Not right now.
I'm saying correctly, the statistics, you've got 100% record in predicting what the mystery app is not going to be.
Well,
right? So whatever you say, you pretty much have been spot on every time. You say, well, you know, it's not going to be this.
So we know the pool.
There's Starbucks.
There's like 30 codes that it could be. So we got a 1 out of 30 chance.
And we got Alexi.
However, if we're using Open Monte Carlo, we could probably improve it.
Correct. But I think with your ability, you just need to invert your
I think you're right.
and at least sometimes knowing what something is going to be is just as important as knowing what it is going to be. So,
That's right.
you know? So you should position yourself as
This is the guy in.
predict what it's not going to be. And you've got 100% track record. So perfect.
Oh, I see.
And if I go to 30 of these, I'll have 100% negative success rate.
Which is very positive. And if you keep that up, then you could go into marketing. You take a bad number and make it look seem like a good number.
Yeah.
I mean, there's several jobs at some of the major corporations that have that kind of skill set.
Oh, yeah.
Are you going towards mirroring? Is that what you're
But again, I think the order is traditional. So I play that's
It's only recognized as displays.
Do you want to just go straight HDMI and we'll just do the audio off your laptop? It won't go to the house system.
Well, we have two problems. One, I don't think Alexi, Charbucks, you guys there? Doesn't really seem like they can hear us, and we can't see the video. Although I can see them. It's kind of a small screen. Charbucks, are you there?
Is this the first time you're doing this with the laptop?
No, we did it earlier.
We did it Friday.
You remember how it was done?
Yeah, we didn't.
Hello.
We didn't go HDMI to VGA to HDMI. That's for sure.
Yeah. Who's there? Am I there?
Nothing showing up the screen here yet.
Well,
you need to do whatever you need to do to turn on the.
No. Let's just go straight HDMI. We weren't planning on going to a video system. But we'll just go, and then we'll have to have audio on the speaker.
You got HDMI?
Yeah, we just won't get audio though. We won't get house audio.
I was thinking like.
Oh, you were not.
Another record of exploding.
Alexi, Charbucks, you there?
I thought you were an expert.
Says the connection's good. Is there a volume on this?
Yeah, the volume's fine. But it hasn't moved since Friday.
No, you just press it.
Well, it's currently the audio is connected. Which is what we had on.
Yeah, but your video
our engineering content. Right, video is. I think what we're.
Video, you're doing a video.
Still not showing on the screen.
Yeah, give it.
If it's okay over here, that means it's on the laptop.
Yeah.
Well, given the choice of rather
Thanks.
You have a laptop?
Yeah.
You have a laptop? Is it at the BG?
Is it like midnight? I mean, is there some arbitrary?
I think it's midnight. I think it's midnight.
I'll look at it tomorrow.
Yeah, I was actually gonna check. I'll let you know. All right, now only have it.
Right.
Alexi, is there any chance?
I can also talk about it.
So I think we will hear back either positively or negatively. I got a query in our Qualcomm query in Calais on something, so we'll hear back from someone.
Is that the audio?
So for now, I should just.
That's everything.
That's everything?
But no Jensen side.
No, I mean, that's recently, that's our fault.
Right there?
Right. Yeah, so by the time we have to, like, if they come back and say, yeah, we're accepted.
Oh, yeah.
last time we just played it safe.
Oh,
Yeah.
yeah.
A lot of people.
Starbucks, are you there? Can you hear me?
Just the safest bet.
I have no audio from Starbucks.
I'll let you know when the
Like we're, I guess we're trying to
that should be done by.
Okay. That'll be fine. Thank you so much.
I'm super seeing their reputation.
No, that's okay.
This is like very intimidating.
but yeah.
Jetsons? Yeah, because I'll have a ton of them at the Open Supercomputer booth anyways, and if we just bring them over to the SEC. Yeah. Thanks a lot. Yeah, appreciate it. Yeah, and I'll email some. Yeah, that'd be great. And then we can get in touch with
Because this is connected to your BG.
Thank you.
No. This is connected to BG.
Well,
I'm going to put this on BGA and not see it.
is it a loose cable on the audio, possibly, Brian? Did we wiggle it or something? We did wiggle it.
I hate you.
We did more than wiggle it.
By the way, that was Aerosmith. Not even heavy metal. Okay, we'll turn the volume down.
Yeah.
I'm turning the volume down.
I dislike
What?
those.
I can't hear.
I can turn the volume down.
Can't hear anything.
No, that reminds me, speaking of Aerosmith, one about 5 years ago, supposedly Aerosmith was in like a bar or something, and the music was, some of their stuff was playing over the loudspeaker, and Tyler was like, oh, these guys sound pretty good, and Joey, can
you count to 10?
Joey Kramer, the
1, 2, 3, 4, 5, 6, 7, 8, 9.
Anyway, he said,
Beautiful. Okay, Hong Kong's connected. Hang on a second.
That's
us. Alexi, are you there?
Yes, I am here.
Wow. Okay, good. Folks, we can all reconvene now. Is that okay?
The wiggle.
This is about the wiggle.
That's the wiggle.
The wiggle works.
We can know a piece of cold pizza.
Okay, so.
Do you want to take a moment to see if we can do both video and audio? Do you want to say just audio?
I think audio.
Carlo will go.
Video. Okay. That's okay. Okay. Is that? I think that's.
Sure, yeah.
To do. Okay, so thanks for enduring that. It's the cable boss. It's the cable boss. So what we have two folks on the line. One is Alexi from the EFF, and he's going to talk about Privacy Badger and sort of a little bit of a theme around privacy. Of course, all the stuff that's been going on with Facebook and the congressional hearings, and there was a new thing that was announced today, which is this cyber tech group affiliation of 30 plus or something like that, high-tech companies, and so there's kind of a lot of cool cyber stuff. So first we'll have Alexi talk about Privacy Badger. Go for about 10, 15 minutes. If you have questions, anybody in the room use Privacy Badger at this point in time? Me? So actually a handful of people. Alexi, did you hear that?
Yup, I'm glad to hear that.
Okay, great. And then after Alexi goes, he'll take some questions, and then we'll switch over to Hong Kong and Starbucks. Okay. So Alexi, take it away.
Do you guys have the slides up on the screen?
We don't, and I apologize for that. The best we can do is post them after the fact, I think.
You could give us.
Okay, got it.
Okay.
So
these guys can get in with their URL though.
We actually, what we can do is we can we'll put the URL up on the board, okay? As you speak.
Okay. I just pasted the link in chat on Jitsi.
We can do a miniature denial of service all from the same room.
Actually, he said with Jitsi, we're probably good with 20 computers. Is that what he said yesterday? So we could give the Jitsi URL too.
We could do that.
Yeah.
But he's just, anyways, Alexi's just audio anyways, so there's no video on his own. So I'll work on that, Alexi. If you can just Alexei is having connectivity issues.
It's those evil corporations that are getting in the way of privacy.
You know what we'll do?
Yeah, I think Facebook is trying to block his connection.
All right, so what we're going to do is make the quick switch from San Francisco to Hong Kong. And Charbox, if you could take it from here. Give him the rundown. We gave him a tally on your millions of videos, but take it from here.
Yeah. Hi, I'm Charbox. I'm from armdevices.net. So I try to have a French accent because I'm from Switzerland, but I'm in Hong Kong right now at the China Fair where they have lots of cool technology. There's like 6 top exhibitors, they all come from Zen, showing basically iPhone keys and, no, that's not quite, but there's a lot of, they're trying to innovate, you know, because they're all kind of going out of business with the tablet market crashing and stuff like that. I was at the supercomputing event a few months ago where I filmed the awesome Boston team. I think you won, right? I think you beat...
Yes, we won.
You beat the Chinese, right? I think Trump is hoping that you will beat the Chinese at least next time. Without using ZTE or Huawei hardware. But you cannot see what I'm doing, right? There's only sound.
Only sound.
There's only sound, but you sound great. You have a great connection.
So my website is called armdevices.net. I've been doing that for 15 years, talking about the ARM stuff, because I'm sure Intel is just about to die. I mean, I've been thinking that for the last 15 years, but I think it's happening now, because everybody's ditching Intel, right? I mean, we'll see. Yeah, especially China. I think there's a good chance China will try to find something, an alternative to the big American chipset. So maybe, you know, right now ARM is Japanese and Saudi Arabian. Who knows? Maybe it's going to be acquired by the Chinese soon, and maybe there'll be even some more ARM stuff going on. So maybe, well, I'm kind of looking forward to the ARM-powered supercomputers. So maybe if you want to win next year, if you want to beat the Chinese, I think you have to focus on the ARM technology. I mean, that's just my, kind of like my, I say all the time. I just say ARM, ARM, ARM. That's why my website is called armdevices.net. But I wonder, are you using any ARM in your you talking about supercomputers, right? Do you have some ARM going on?
So the BU team might be Qualcomm.
Yeah. So
as soon as you said Qualcomm, he cut out. What was the deal there? Oh, he's back. He's back.
Yeah, am I back or Alexei?
No, you're back. You're still on, Charbox.
Yeah. So I did this interview a couple of weeks also with a company called HXT. And HXT is the new.
Sorry about that, but this is really
the whole connections that disappeared. That's all. Yeah, so HXT is in the Chinese Qualcomm, basically, also coming with a server chip very soon. It's probably just going to be the same as the Qualcomm, but it's just going to be named HXT for the Chinese market. My new phone is a Gemini
I think what's happening here is we're getting feedback from people connecting to that URL.
Yes.
If everyone can disconnect from that, that'll fix the problem.
It's either that or Aerosmith is like down the hall.
Either that or turn off your mute your microphone.
Yeah, mute the microphone. I'm sure that's what it is.
It's up to someone back over there.
Well, somebody still has it on.
It's got that Twilight Zone effect, though, doesn't it? Try again, Charbox.
Yeah.
Someone still has it on. Okay, who in the room is still connected to that? Can you disconnect? Or
Yeah, so.
Okay, if you're not going to turn it off, we're going to have to tell him to shut his end off and start a brand new session on a different URL.
I'll try again. Actually, I see there's a fellow Jitser here. The microphone is muted, but they're still hanging in there.
Hi, I'm sorry, I had connection difficulties earlier. I had to restart.
Okay, over to Alexi in San Francisco. How are you, Alexi?
I'm okay. Sorry about the connection trouble.
That's okay. Charflex, if you could just kind of park it at the red light for a moment, please. Sorry. And Alexi, if you want to kind of give a rundown on what Privacy Badger is all about.
Oh, sure. I can do that quickly. So it sounds like we have some Privacy Badger users in the room. So some people are already familiar with it. But for those who are not familiar, Privacy Badger is a lot like AdBlock Plus or Ghostery. But unlike AdBlock Plus or Ghostery, Privacy Badger doesn't come with a list of domains to block. Privacy Badger learns what to block as you browse the web. And the way it does it is it looks for domains tracking you, and once it sees the same domain track you across 3 different websites, Privacy Badger says, that's enough, I'm going to start blocking you. So one example would be whenever you see a Facebook like button on a page, you don't have to do anything for the Facebook like button to track you, to record your presence. So once Privacy Badger sees Facebook like buttons on, I don't know, The Guardian, Washington Post, and New York Times, it says, okay, that's enough, that's a tracker. So that's the big difference. And because of this difference, developing Privacy Badger is much, I think, much more tricky than developing something like Ghostery, and I previously worked on Ghostery. So with Ghostery, you have a list, and then you work to make the list better. And with Privacy Badger, sometimes you don't even know why you decided to block something. So you have to kind of reverse engineer what happened. A lot of these issues are little mysteries for us to solve. So the big difference is Privacy Badger works differently by design. And because of that, debugging problems is more difficult. And our big problem is Privacy Badger still breaks a lot of websites. Does anybody in the audience, do any of the Privacy Badger users have any questions for me?
Any questions of Privacy Badger users? How does it work? Or how does it identify when trackers appear on pages? What's it looking for? Is it just kind of parsing through the HTML stuff, or?
Yeah, so that's a good question. So what happens is whenever you request a page, you request every resource on that page. And when you do that, you make a request and the page responds with something. And sometimes the page responds with cookies. It says, hey, even though you requested this image graphic, I also want you to set a cookie, set a little text file containing the following information. Usually they're tracking identifiers. So Privacy Badger watches what happens as you browse, and it says, I think this is a tracking cookie, so I'm going to take note of it. I see that Facebook.com does not belong to the same entity as the site you're on, as NewYorkTimes.com. So I'm going to say this is a third party or external tracker, and I will record the fact that I saw it put a cookie in your computer. And once it sees the same domain try to place another or the same non-trivial cookie on 2 other sites, is going to say, that's your 3 strikes and you're out. And cookies is just one mechanism that you could be tracked, right? So we, in addition to cookies, Privacy Badger also looks at local storage, or HTML5 local storage, or super cookies. And it does the same thing. Is this third-party domain trying to place some non-trivial tracking value across several different websites? Well, I'm going to consider that's a tracker. And another method that Privacy Badger looks at is it examines JavaScript that works on web pages. And it says, hey, I think I think what's happening here is this JavaScript is trying to uniquely identify my computer because it's doing something called Calais Fingerprinting, for example, which is a kind of tracking technique where nothing gets stored on your machine, but an identifier is created anyway. And the way this works is the tracking script asks your browser to draw some invisible image off screen. And because everyone's video card and everyone's operating system and everyone's set of installed fonts differs just a little bit, because of all these factors, the way your browser actually draws that image on the screen is a little bit different for everyone. So it's that you can take that image, the tracking script takes that image and it creates a tracking identifier out of it. Now what Privacy Badger can do is it can look at the JavaScript doing this work and it can say, I'm pretty sure this is Calais Fingerprinting because nothing legitimate would write out some image data and read it back right away this quickly, you know? So then if Privacy Badger sees this happen, it says, okay, I think this is a tracking script. And because there are so many different kinds of tracking techniques, this is just the beginning. So the two big problems for Privacy Badger is that it blocks too much, meaning it breaks sites, and it doesn't block enough, meaning that it doesn't detect some trackers, even though they're pretty clearly trackers. So my big task is to keep refining Privacy Badger by breaking less and blocking more. And our eventual goal for Privacy Badger is to make it something that you can set and forget on anyone's computer. It doesn't have to be a technical person. It could be your relatives, your friends, doesn't matter. And you shouldn't expect them to have to interact with Privacy Badger. It should be set and forget. So you want it to be something that you can put on people's machines and it'll make their browsing a little bit more private from commercial surveillance. That's our goal.
Any questions?
Actually, one. How will doing something like find, say, in .firefox or the appropriate directories, -iname, cookies, or star cookies star, and then basically piping that to a shell script that removes all those files and replaces them with symlinks /dev/null, will that cause problems for Privacy Badger? i.e. your browser, i.e. your browser has amnesia about cookies. Every time it closes it forgets them.
Right, so you're saying what happens if I remove cookies periodically? Well, I think it shouldn't make a big difference to Privacy Badger. It really depends on how often you remove cookies. If you remove cookies after every single page, then Privacy Badger doesn't get to learn when cookies are sent out with your requests, you know? Privacy Badger looks at when cookies are being set, and Privacy Badger looks at when cookies are being sent. So if you've cleared your cookies as frequently as you can, meaning after every single page load, let's say, then it doesn't learn from cookies going out. But I think effectively speaking, it shouldn't make a big difference. So it's not that Privacy Badger looks at which cookies are on your disk, it's that Privacy Badger looks at the activity. So what are the cookies that are incoming and outgoing? And what are the local storage entries that are incoming and outgoing?
So running it in incognito mode is fine, as long as you basically don't restart your browser every 10 seconds or something.
Yeah, it's totally fine. Now, I think there is a related question that you could ask here. You could say, hey, what if I'm using another blocker, right? Does that mess with Privacy Badger? And my answer is yes and no. I think it's totally fine to use several blockers together. A particularly good combination is uBlock Origin and Privacy Badger. And what's going to happen is Privacy Badger is going to learn a lot less because uBlock Origin will get to block it first. But that's fine, that's okay, because uBlock Origin is based on lists. And if there's a tracker that uBlock Origin doesn't know about, then hopefully Privacy Badger will learn about it.
question from the back?
That was my question.
That was your question, good. Yep.
So does it track these lists, and can you put them in like uBlock origin afterwards?
That's an interesting idea. So if this is a good follow-up proposals. I don't know if you have a GitHub account or you can just send us an email, but I would like to see this posted on our GitHub. So you're saying, what if we did some kind of study, maybe set it up to run automatically and said, hey, what are the trackers that Privacy Badger finds that uBlock Origin doesn't know about? So that's a cool idea, and we haven't worked on it yet, but we could do it in the future.
So we can get him your email address, Alexei, and you can connect there somehow. That's great.
Yeah, actually, if you just go on GitHub for Privacy Badger, if you just click on Privacy Badger's homepage, aff.org/pb, right? It'll link you to our GitHub account, and there it'll tell you how to get in touch. Or I think the homepage also tells you how to get in touch. And my email address, if anybody wants to ask me follow-up questions, it's alexei@eff.org, ALEXEI.
Great. So I might. This actually worked great, Alexei. It was Alexei's suggestion to try Jitsi, and the audio quality has been really stellar. And I'm amazed actually at the ability of you to hear the questions from the audience, even from people, at the back of the room. So maybe what we could do is we could do kind of a 6-month checkup here and find out, if there are a handful of hands that went up today, what it might be like in the future. But otherwise, are there any last-minute questions for Lexi? Otherwise, we can kind of let him go, and we can follow up again at some point in the future. Anything else, Alexi, for the time being? Any parting thoughts on privacy and in this day and age of online living?
I guess it's privacy is the process and a way of thinking, and there is no automatic program that will protect you. It's kind of something that you have to think about and consider how much data you put out.
That's great. Well, if we can give you a long distance applause, we appreciate you taking the time out to meet us. Thanks, Alex. Thanks. We'll talk. Charbucks, any chance you're still there?
I think one important takeaway from this is we definitely don't want 2 different machines connecting to the same Jitsi thing in the same room.
Yeah. So I apologize. You got a flavor for Charbucks. Kurt and I have actually for a long time been trying to get that guy to blow through here during one of his across universe travels. And I think this is the first time we've actually met him live. Charbucks in any way, shape, or form. So maybe what we can do is we can post along with the notes to this meeting, maybe a few of his video clips and further follow-up. But he did, and they were both really patient, as were the people here. So thank you for that.
So you can turn your laptop around, right?
So this is, and you folks all know this stuff, but so this is a fairly new laptop. It's an 8th generation Intel, and the reason I got it actually was so that I could do kind of more 4K stuff with, so you can get 43-inch 4K TV screens. How many people use these as like monitors for like $300, right? And I mean these are, at Costco you can get. They actually have a 40-inch 4K for $289, and so with the 8th generation, it has built into it the video, graphics capabilities to be able to support basically that. So if people are doing large spreadsheets or programming and you want lots of screen space, so this laptop, which is an i5, it was under $500, and so you get a laptop and it's got Ubuntu and as well as Windows, and it's got a terabyte drive and 12 gig of RAM. And so for $800, you've got screens galore. So the technology is just really amazing.
So what model is that?
It's an HP Pavilion, and it's the i5, and it comes in all kinds of different flavors and configurations.
Apparently it's got a pretty good microphone on it too.
It apparently has a good microphone and a pretty good camera. But the one thing it has, somebody asked the question about, can you turn it around?
Well, so
unfortunately, when you turn it around, it ends up kind of, it's a touch screen. right? So you turn it around, but somehow Ubuntu flips the screen upside down, and then, actually what it flipped it, which was pretty cool. It flipped it sideways, but it's got a few quirks to it that are anomalous, I would say.
It's probably the touchpad or touch screen driver stuff, because I have a ThinkPad, and on GNOME at least it'll flip. But on KDE it doesn't.
Yeah, it does that. So the last thing, I'll just give a pitch that I'm not going to launch into at this point, but the other thing, I got a bin full of Raspberry Pis, and the new Raspberry Pi B+. Has anybody seen it or used it or worked with it? $35. It's an unbelievable device that I think, does it have a gig of RAM, and it's got 4 USBs on it, and it's got HDMI, and you can of course run it off a 5-volt. And I picked up a bunch of these Raspberry Pi 0Ws for $5 or $10 at the local Micro Center store, which doesn't have as much RAM and it's not nearly as fast, but of course they all have Wi-Fi as well. And the other thing that the B+ has on it is it's got an Ethernet connection. So for what I've used it for, have people used the Go language at all for programming?
I've compiled stuff with Go, but it was just so I could do packet capture and stuff with BetterCat or whatever.
So it does. It's got terrific networking. It's this open source language that was developed out of Google some years ago. It's now 1.10 is sort of the version of it. It's got terrific library support for a bunch of different areas, especially networking stuff. It runs on all the big main common platforms, and sort of what I've used, it runs on the Raspberry Pi, but it also runs on IBM mainframes actually, and everything pretty much in between. But another point of this talk was to talk a little bit about the cloud stuff. Have people used AWS at all? So some people have, and some. This is really and truly a revolution. It's kind of almost a shame for people who are just, or fortunate, I guess, for people who have been introduced to this at day one. But for other people who have really labored through establishing hardware, or test labs, or Charbox, are you still there?
Yeah, I'm back. Sorry.
Oh, you.
So that was my question. Can we watch him on your screen?
God bless you.
For sure, it was moot at this point. But,
well, Charbox is back. So well, here you can take over.
No, can you just turn the screen around?
Well, unfortunately, he's gone dark on me. So this is the dark.
Hey, what's up?
Wait, hang on. We'll plug you in again. And I apologize for the cutaway there. Are you there?
No problem. No problem. Maybe it's because I'm using.
We have
Can you hear that?
We have a little Wi-Fi lag or something like that going on.
Okay, I'll turn off my camera. Maybe I'm too far. I'm in Hong Kong. Maybe I shouldn't have my camera on.
Or just come to Cambridge. But yeah, if you turn the camera off, it actually it may be better.
Say hi to the NSA.
Yeah. So are you in the MIT, right?
Yeah. We'll send you a picture.
That's really cool.
Of you on the screen.
So one of the reasons I'm video blogging is because of the amazing MIT Media Lab project called One Laptop Per Child, which was an ARM-powered laptop project. It was one of the original projects to try to kill Intel and make laptops cheaper around the world. And that was really amazing, and I think they kind of succeeded in some ways. Like they forced Intel to half the price of all laptops in the world, so that was good. But it's not quite enough. I'm doing videos about ARM devices, but what I really want to see is more ARM-powered laptops. I want to see stuff where people buy products that are in the market of the consumer Intel stuff. So I've been using ARM-powered laptops exclusively since 2012 because there have been a bunch of ARM-powered Chromebooks, which is what I'm using right now. I'm using an ARM-powered Samsung Chromebook Plus, which I think is the coolest device in the world. It's really fantastic. It's like $300-something. You can find it maybe. It's very thin and light, but maybe it crashes. I don't know. Just before, when there was a bunch of people joining the chat, something crashed. But I mean, it seems like a really nice open source video chatting system here.
Your audio
also streaming.
Your audio is great right now, Charbox. I mean, we don't have video, but the audio is fine.
So what do you want to hear about Hong Kong? Do you want to hear about the smells or the noises?
The food. Are the tech centers for shopping? Does the stuff just come directly in from Shenzhen and get offloaded into the markets of Hong Kong?
Well, one of the things about the Hong Kong, as far as I understand, is that it's a lot of stuff that you don't quite get it in Shenzhen, because in Shenzhen there's a Chinese tax on everything. So actually, if you want to buy an iPhone in Shenzhen, there's like a 50% tax on it. So you have to pay $1,200 or $1,300 for an iPhone.
That's where they're made.
So the Chinese, they kind of like going over here to Hong Kong and buying it for $800 and saving $500. But if you want real cool stuff, I think it's better to find it in Shenzhen, which is actually just the last subway stop. It's the last subway. It's Shenzhen, so it's just 45 minutes from here. And then Shenzhen is 50 million people, because there's all these cities around Shenzhen that are kind of growing into Shenzhen. So if you take all of Shenzhen, it's 50 million people. It's become the biggest city in the world. The average age is 27. It's just a bunch of young people all over China. They're coming to dominate the world of technology, kind of. They just make everything in Shenzhen in 2 weeks. You just, if you have an idea and you have $5,000, you can get them to do whatever you want, which is pretty awesome. It's so cool to walk around with all these design houses that are in Shenzhen, where you can just come up with some ideas. You can start with a development board, and then you can say, hey, I took this all-winner chipset, and the chipset is only $5, which is an ARM chipset, and then you can do whatever you want. You can make a smart vacuum cleaner, or a smart bed, or a smart sofa, whatever you want.
So
they'll just do it.
There are some smart people in the room here. If they have ideas for things like the smart vacuum sofa bed, they can get in touch with you, and you can help connect them with the right people?
Yeah, or you know, it's $400 return flight. So next time you buy an iPhone, I mean, I hope you don't have iPhones, but it's the next time you think about buying an iPhone, just don't buy an iPhone, and then you can fly to China. You can fly to Hong Kong for half the price of an iPhone, return flight, and then you can spend a couple of weeks and visiting all these little design houses, and that's actually the most important thing that they need right now. I'm not trying to say that they don't have ideas, but they really need new ideas. They need something to not stay alive, but to come up with a new, basically come up with a new iPhone. So because the smartphone market is getting kind of cannibalized, and maybe the prices are going to go down eventually, hopefully.
So you think you could arrange it?
Would
Would you arrange a tour if a group of people wanted to go over and visit en masse with you? Would you tour people through some of these design houses that you're familiar with?
Yeah, let's do that. Let's next time something blows up, like with Trump or North Korea or something, we could just we could go on a tour that goes by North Korea on the way, if you want, so we can cheer for Trump when he has a meeting.
Has the tariff affected? What do people think of that? Because it's significant. I mean, we are effectively in a trade war with China. And it sounds like, I mean, even Hong Kong is in a trade war with China at this point. But what do people think about that?
Well, I think hopefully it could be quite fantastic. It could be quite great in a way that I've been waiting for a very long time. Because I'm not only an Intel hater, I'm also an Apple hater. I don't know if you heard. But
right on.
I think there's an opportunity right now for China to ban the iPhone. Because basically the US has banned Chinese phones from the US market. So I think China should just say, oh, you want to ban Huawei and ZTE? We're going to ban the iPhone. And by the way, the Qualcomm chipsets, we're going to make our own, Okay, maybe that's not very positive, but I'm just saying this is quite exciting. I'm saying there's a chance that maybe, Apple, 90% of their profits are coming only from the iPhone, not even from the iPad or the MacBook or anything. It's just the iPhone. So the way that I'm hoping they're going to ban it is not just the sales in China, but actually the manufacturing. Because Trump really wants to make iPhones in the US. So I think China should just say, okay, good luck. Try to make them in the US.
I mean, he's an anti.
I'm not anti-American, you know. I'm just
No,
I'm just thinking it's exciting. It's exciting times. I think Trump is a really funny kind of character.
Can I ask a Linux question?
We have a question from the back. Yeah.
Since this is the Linux group, can you tell us a little bit about what you're running on your Samsung Chromebook? Like what Linux, and if you had problems with certain distributions or some work better than others?
So Google is doing a little bit to help people. You can crouton it to some different kind of Linuxes that are running quite okay. It's like a Rockchips processor, which is very interesting. So it's a Samsung Chromebook, a beautiful, ultra thin, ultra light, the most nicest, thinnest laptop I've ever seen. But then it runs a Rockchip processor, which is a Chinese ARM processor, dual core A72 and quad-core A53. But the thing about this chipset is that it's 28 nanometers, so it's not even the latest of the ARM. You know, it's like 2, 3, 4 years old kind of technology. So what's happening right now, which is also very exciting, is that there's a bunch of Qualcomm powered laptops coming out, and they are using the Snapdragon 835. And what I've heard is that you can go into the BIOS and you can disable secure boot. So you can actually install Linux on them, so you don't have to run Microsoft. I don't know if you're big fans of Microsoft, but you don't have to run Windows on the ARM. You could potentially just run any Linux you like. And it's actually a very, very powerful 10 nanometer ARM processor on those.
I think you meant you don't have to run Chrome OS, you can run your favorite Linux distribution, right?
Yeah, you can run any kind of Linux. There's a bunch of Linuxes that work. You can just run those if you want. But
what are you running?
Maybe I'm boring. I don't know. I just use Chrome OS. I think it's very simple and it works. But of course, I'd like to see some improvements in the Chrome OS. Maybe support for some different application. Right now, the last few months they added support for Android apps in Chrome OS. But it'd be nice if they could add support for other kind of Linux apps.
Great. Any other last minute? One question from Kurt, and then we'll give you a round of applause, Charbucks. But thanks a million for joining us tonight. This is great. Kurt, you can wrap it.
Hey, Charbucks, are there any RISC-V products coming out of Hong Kong?
So, you know, RISC-V is very interesting, but what I think RISC-V is maybe some Intel employees to kind of disrupt what's going on with the ARM. Maybe, I'm not sure, but it sounds like there's a lot of companies that are supposedly joining the RISC-V, but I think they're just doing it to put pressure on the ARM and keep the prices low. So we'll see what happens, but I don't think this, I mean, we'll see. I mean, it's very interesting. I'm just about to post a half-an-hour interview with the founder of the RISC-V that I filmed at the Embedded World. I just need to write some text. Actually, I have a lot of backlog of videos. I just filmed too many videos that I don't have time to publish. That's the problem. Basically, I just filmed them for myself, and I'm not even putting them on my YouTube sometimes. Well, no, it's not true, but
if you post that video of the interview, then we will certainly include it in the meeting wrap-up, if that's okay.
Cool. Okay, I'll send you the secret link, so you'll be the exclusive first ones to see it if you want. I also posted a very cool half-hour, very full interview of the student cluster competition from the supercomputing event in Denver. You know, I don't know if you saw that, but it's cool. It's all those students doing their supercomputers.
Charbucks, thanks a million for joining in. We appreciate it. Back to you guys. So, thanks.
So his website's called armdevices.net. He's got charbucks.org, but armdevices.net is the site he's talking about.
I don't recall us having done anything, certainly not San Francisco and Hong Kong in the same evening. And all things considered, once we finally get the thing plugged in and working, it more or less worked okay.
Yeah,
right?
It's truly a global village.
So it's okay. Thank you very much.
Jitsi was working pretty well.
Yeah.
So as long as we remember to turn off your microphones.
Well, and he also said he thinks if we had more than 20 people logged on, then it would probably crash, but it sounds like it crashed before that.
Well, that wasn't a crash, it was just the feedback.
That was
because of
microphone feedback.
microphone
Yeah, just so
feedback.
you realize, it's unbelievable that it actually wored. I mean, you know, Kurt and I were here like on whatever it was, Tuesday or Monday, or, you know, just kind of plugging wires to, Kurt's like jiggle it a little bit more, you know? And that's the key.
We
So,
forgot the Vaseline.
we actually might, you know, if you would do it again, but we did think that this is a wonderful way to get amazing people, Jerry and John as the organizers of this meeting. It's, you know, you can kind of invite somebody to come online from the comfort of their, you know, hotel in Singapore, right? And they'll actually join you. Or of course they'll never fly.
Yeah, most companies use video conferencing software. I know at Red Hat we used Blue Jeans, which was very similar to this. Or there's WebEx and a couple others.
Yeah, and this is Jitsi.org. I mean, it's free.
Yeah.
It was easy to use. We had some glitches with the built-in classroom system because it doesn't have, you can't get access to the audio, the mic, and the camera. So and then we had this other system but the audio wasn't really going out. So there's some glitches, but by the next time we do this, it might actually work.
Yeah.
Well, you know, you could just plug into the back of the projector.
Or we could get
right. I'm saying you don't actually have to. It's low enough that you could actually. There's VGA, there's HDMI, which are not, and DVI, which I can see from here that are not. Right.
So the problem is you've got two projectors.
Yeah, no, well, we can survive with one.
Yeah, for sure.
I'm saying, like,
I'll bring the ladder next time and climb it.
Or we could do it with the audio. So the tricky bit was, I think if we had a proper $20 HDMI cable, we would have gotten audio.
So and even if it was in a different room, it might have just, you know.
On the third floor.
Also, in addition to the ladder, you also want to make sure you get liability insurance.
Yeah, right. But so John, you would have picked up the audio on the streamed broadcast for the audio recording as well?
If it had been working with HDMI, then yeah, I would have picked up the audio.
But, so the audio is taken from the HDMI connection, is how that works. Gotcha. Good to know, but that was great. Okay.
Yeah, the thing also had that VGA adapter, but this is the first time I ever tried to use it.
Yeah, no,
I think the only reason we were having the problem was because the other end of it was loose.
Was loose.
Nobody had to do that.
Right. Okay, thanks.
Okay.
All right, well, there's some pizza left if you guys want it. Otherwise, it's going to vultures@mit.edu.
Yeah. We're done here.
Whatever's closer.
Did you see the clipboard with the guest book on it?
It's behind.
Yeah, make sure you clean up after yourselves, please.
Yeah.
So I just wanted to know.
Kurt, were you on last year's season? I was. And then would you adjourn?
Then I should follow up, check it out. Instead of me to check it out.
As soon as I stop it, it'll
Go there. Oh, yeah. So you may go the trip and so that may be a good model. They're putting 2 InfiniBand cards per group, so yeah, direct. Okay, that might be So it's a legacy of like system admin from 10 years ago. Nobody has power on it anymore. Everyone's new
I was talking to a guy here, he used the instructor who I used to hang out with coffee bars, discussing the different nationalities and things.